Have you ever just stared at a massive spreadsheet, just full of numbers, and felt completely lost? Like you're just guessing at what it all means? Well, the truth is, raw data can be incredibly deceptive. In this explainer, we're going to dive into how you can stop guessing and start seeing the story your data is desperately trying to tell you. Okay, so let's get right to the heart of the problem. A single number, like an average, can lie. Seriously. Imagine your data has two completely separate groups hiding inside it, what statisticians call a bimodal distribution. It's kind of like having data for both house cats and lions all mixed together. The average weight might fall somewhere in the middle, right? It's not going to represent either group. It completely misses the real story. And that is the crucial question, isn't it? If those summary numbers can't be trusted on their own, how do we get to the truth? How do we go from a blurry, abstract table of numbers to a clear, undeniable insight? Well, this is the answer. Data visualization. It's the magic bridge between raw, messy statistics and actual human insight. What we're looking at here is the goal, turning that tangled mess of data into a clear visual dashboard where patterns and outliers just pop right out. It's all about making data understandable in a single glance. Now, to do this, you need the right tools. Think of this as your data detective's toolkit. We're going to focus on two of the most powerful visualization libraries out there in the Python world, Matplotlib and Seaborn. First up is Matplotlib. This is the foundation, the absolute bedrock of Python plotting. Think of it like a complete workshop of high-quality hand tools, your hammer, your screwdriver, your precision measuring tape. It gives you precise, granular control to build literally any chart you can imagine exactly how you want it, down to the last pixel. And then you've got Seaborn. Now, if Matplotlib is the workshop, Seaborn is the set of specialized power tools. It's actually built on top of Matplotlib, and it's brilliantly designed to create beautiful, complex statistical plots, like heat maps or violin plots, with just a single line of code. It's all about speed and efficiency. So the really crucial point here is choosing the right tool for the job. Do you need to customize every little detail for a final publication? Matplotlib is your best bet, for sure. Do you need to quickly explore your data and understand complex relationships? Well, that's where Seaborn becomes your go-to. One gives you ultimate control, the other gives you incredible speed. Now, having the tools is one thing, but knowing how to use them, that's everything. Visualization isn't just about making pretty pictures, it's about interrogating your data. You have to ask the right questions. The very first question you should always ask is about the fundamental shape and spread of your variables. Before you even start looking for relationships, you have to understand the character of each piece of data. Is it skewed? Are there any weird outliers? Where does most of the data cluster? And we have specific tools just for this. A histogram, for example, quickly shows you the frequency, the buckets where your data falls. A box plot is fantastic for seeing the range and key statistical markers, like the median and quartiles, which divide your data up into quarters. And a violin plot? This one's my favorite. What's so cool here is how it combines a box plot with the actual density curve, giving you the richest view of the distribution's shape. Okay, so once you understand the individual pieces, the next detective step is to look for connections. How does one measurement affect another? Is there a hidden pattern when you look at 2, 3, or even 4 variables at the same time? This is where the big insights are usually hiding. For this, we use a different set of plots. The classic scatter plot is perfect for comparing just 2 variables. A pair plot, well, that takes it to the next level. It creates a whole matrix of scatter plots for every variable pair in your dataset all at once. It's an incredible overview, almost like a suspect board in a detective movie. And a heat map gives you a simple, color-coded grid that shows the strength of correlation between all your variables at a single glance. All right, enough theory. Let's see how this all works in a real investigation. Let's put on our detective hats and solve a case using the famous Palmer penguins dataset. So here's our mission. Can we tell different penguin species apart just by looking at the length and depth of their beaks? Our evidence is the dataset. Our method is a simple scatterplot. But the key, the real moment of discovery, comes when we add a third dimension, color, to represent the species of each penguin. So let's see what happens when we apply this clue. And this brilliantly illustrates the power of visualization. I mean, look at that. The moment we add color, the insight is undeniable. The Gen 2 penguins form their own distinct cluster, and while the other 2 species kind of overlap a bit, the Gen 2s are clearly in a league of their own. A simple chart instantly answered our question in a way that a table of numbers never, ever could. Case closed. So as we start to wrap up, let's zoom out a bit. The ultimate goal here isn't just to plot data, it's to find and tell a compelling story. Every single chart you make should have a purpose. It should be a direct, clear, and honest answer to a question you asked of your data. You start with a question, you use the chart to find the answer, and you arrive at an insight. If it doesn't follow that path, it's really just noise. I absolutely love this concept because it sums up the entire philosophy. Your job as a data storyteller is to be a ruthless editor. You need to remove all the distracting chart junk, the unnecessary grid lines, the confusing labels, and do everything you can to make the core insight, the signal, as clear and loud as possible for your audience. So the next time you're faced with a wall of data, just remember that there's a story hidden inside. It's talking. With the right tools and the right questions, you have the power to uncover that story and share it with the world. The only question left is, what story will you tell?